Hi, my name is Marilyn, and in this video I am going to describe to you my poster. On my poster, starting right at the top, I have a rectangular prism. I have the net of my rectangular prism and the folded part of my rectangular prism. In the area below, I have all my parameters, which are the area, perimeter, and volume. So the area of the rectangular prism was the sum of area of each shape on every face. There are 6 faces, 2 of which were squares and 4 of which were rectangles. So I calculated the area of all of the shapes and then added them together. I've used the length, which was 4 centimeters, and the height and the breadth were both 2.5 centimeters each. That gave me a total of 52.5 centimeters squared for the area of the rectangular prism. Moving along, I have calculated the perimeter, and the perimeter of the prism is the perimeter of just the base, which was a rectangle, and the perimeter was all of the sides added up, and 2 of the sides were exactly equal because this is a rectangle. So it was 4 times 2 plus 2.5 times 2, and that gave me a total of 13 centimeters. And lastly was the volume, and the volume of a prism is calculated by the area times its height, and it was 4 times 2.5 times 2.5, which gave me a total of 25 centimeters cubed. The second net that I have, which is the net in blue, is the cube, and this is its folded part. So I've also calculated all the parameters for the cube, which were exactly the same for the rectangle, which was area, perimeter, and volume. So the area of the cube was different in the sense that all the sides were exactly equal, unlike the rectangular prism. So there are 6 faces here, but each face and each side have the same length. And in my particular example, the length was 4. So my total area was 6 because of the 6 faces times 4, which is the length, and 4 is to the power 2. So my total answer was 96 centimeters squared. The perimeter was the perimeter of the square, and all the sides were equal, so it was 4 times the length of the side, and that gave me a total of 16 centimeters. And lastly, in the cube, the formula for the volume of a cube is the sides to the power 3, and the length of my side was 4, so just 4 to the power 3, and that gave me a total of 64 centimeters cubed. And lastly, right at the bottom, the shape in orange and the net in orange, this is the pyramid. So this is the net of the pyramid, and this is its folder counterpart. So starting with the area of my square-based pyramid, I had to calculate the area of the entire 4 triangles and add it to the base, which was square. So I got a length of 5 centimeters and the breadth of 5 centimeters and a height of 3 centimeters. However, the height that I had was the perpendicular height and was not the slanted height, and in order to calculate the area of my square-based pyramid, I had needed to have its slanted height. So in order to find a slanted height, all I had to do was use the theorem of Pythagoras, and I got my slanted height. And I got a total slanted height of 3.9 centimeters. And then that was much easier for me to work with, and then I calculated the 4 triangles area, and I added it to the area of the base, which is a square. And my total area for my square-based pyramid was 34.75 centimeters squared. The perimeter was similar to the perimeter of my cube. It was a simple square, so therefore it was 4 times the same length, and the length in this case was 5, so it was 20 centimeters. And lastly, the volume. So the volume of a pyramid is its base times height all over 3. So I slotted my information into the formula, and I got a total value of 25 centimeter cubed. And if you look at my poster, I have deliberately chosen these specific shapes because they resonate very true in the shapes that we find all around us, with the obstacles and equipment and the tools that we use. And I thought it was great to incorporate these specific shapes, these polyhedrons, also because it gave me a theoretical understanding of the capacity and the area and the perimeter of these shapes, not just only on this page, but in a real life application.